Hello and welcome. Today, we're going to tackle a fundamental concept in chromatography, the void volume. Understanding what it is and how to calculate it is crucial for getting reliable and reproducible results. So, what exactly is the void volume? In simple terms, it's the total volume of the mobile phase inside your column. Imagine your column is packed with tiny particles of the stationary phase. The void volume is all the space between and within those particles where the liquid flows. It's also known as the dead volume and is often abbreviated as VM or V0. Knowing this volume is important because it helps us understand how our analytes are behaving. It sets the baseline. Any compound that elutes at the void volume is considered unretained, meaning it didn't interact with the stationary phase at all. This allows us to calculate other key parameters, like the retention factor. Now, let's get to the main part, how to calculate it. There are two common methods. The first, and most accurate method, is by using an unretained compound. You inject a sample that you know will not stick to your column's stationary phase. For a typical reversed phase HPLC column, a compound like uracil is often used. You run your analysis and record the time it takes for this unretained compound to appear on your chromatogram. This time is called the void time or dead time, written as Tm or T0. Once you have the void time, the calculation is simple. The formula is void volume, Vm, equals the flow rate, F, multiplied by the void time, Tm. Just make sure your units are consistent. If your flow rate is in milliliters per minute and your time is in minutes, your void volume will be in milliliters. The second method is a geometric estimation. This is less accurate but can be useful for a quick approximation. You calculate the total volume of the empty column cylinder using the formula for a cylinder's volume, which is pi times the radius squared times the length, V equals πr²L. Remember to use the internal radius of the column, not the outer one. Since the column is packed with particles, the void volume is only a fraction of this total volume. A good rule of thumb for a well-packed column is that the void volume is about 70% of the total geometric volume. So, you would multiply your calculated total volume by 0.7 to get an estimate of Vm. While the estimation is handy, the unretained marker method is the gold standard for accuracy. Thank you so much for watching this breakdown of void volume calculation. If this video helped you clarify the concept, please hit the like button and consider subscribing to the channel. Your support is greatly appreciated and allows me to keep making these tutorials. Let me know in the comments if you have any questions, and I'll see you in the next video.